A solar panel system consisting of solar panels, battery storage, a direct current panel with a disconnect, an alternating current to direct current converter, and a 12/24 panel with a main disconnect. The first point of disconnect is typically the direct current panel with the disconnect. This is because it represents the initial location where the direct current power originating from the solar panels can be isolated from the subsequent components of the system. The direct current panel must be grounded. Grounding provides a pathway for fault currents to safely flow to ground, thereby protecting personnel from electrical shock hazards and preventing damage to equipment. The grounding conductor should be securely connected to the ground bus bar located within the direct current panel. The bonding point should be established at the main disconnect panel. Bonding involves connecting all metallic components of the system, such as panels and enclosures, to the ground bus bar. This measure ensures that all metal parts are maintained at the same electrical potential, minimizing the risk of electric shock in the event of a fault. Here is a simplified system diagram: solar panels to battery storage to direct current panel with disconnect which is grounded at this point, to alternating current to direct current converter to 12/24 panel with main disconnect, where bonding occurs at this point. The direct current panel with disconnect should incorporate a main breaker or fuse. This breaker or fuse must be rated to handle the maximum current output produced by the solar panels. This ensures that the circuit is protected from overcurrent conditions. The alternating current to direct current converter should be appropriately rated for both the input and output voltages and currents that are present within the system. Ensuring that the converter is adequately rated is crucial for its safe and efficient operation. The 12/24 panel with main disconnect should feature a main breaker or fuse. This breaker or fuse should be rated to handle the maximum current output from the battery storage. This safeguards the panel and the connected circuits from overcurrent situations. Grounding and bonding are essential safety practices in electrical systems, including solar panel installations. Grounding provides a low impedance path for fault currents, allowing protective devices such as circuit breakers to quickly interrupt the circuit and prevent electrical shock hazards. Bonding connects all non-current carrying metal parts to the grounding system, ensuring that they are at the same electrical potential. This eliminates voltage differences that could create a shock hazard if someone were to come into contact with two different metal parts. In direct current systems, grounding is particularly important because direct current faults can be more persistent and harder to detect than alternating current faults. A ground fault in a direct current system can create a sustained arc, which can ignite flammable materials and cause a fire. Grounding the direct current panel provides a path for the fault current to flow to ground, causing the overcurrent protective device to trip and interrupt the circuit. The National Electrical Code, or NEC, provides specific requirements for grounding and bonding electrical systems, including solar panel systems. It is essential to follow these requirements to ensure the safety of the installation. The NEC specifies the size and type of grounding conductors, the methods for connecting grounding conductors to equipment, and the requirements for ground fault protection. In solar panel systems, the NEC requires that the direct current grounding electrode conductor be sized according to NEC Table 250.166. The grounding electrode conductor connects the direct current equipment grounding system to the grounding electrode, which is typically a ground rod or a metallic water pipe. The NEC also requires that the direct current system have ground fault protection. Ground fault protection is designed to detect ground faults and interrupt the circuit before a shock hazard can occur. Ground fault protection can be provided by a ground fault circuit interrupter, or GFCI, or by a ground fault detection system. In addition to grounding and bonding, it is also important to provide overcurrent protection for the direct current system. Overcurrent protection is designed to protect the equipment and conductors from damage due to excessive current. Overcurrent protection can be provided by fuses or circuit breakers. The overcurrent protective devices should be sized according to the ampacity of the conductors they protect. The ampacity of a conductor is the maximum current that the conductor can carry continuously without overheating. The NEC provides tables that list the ampacity of different types of conductors. When installing a solar panel system, it is essential to follow all applicable codes and standards. This will ensure that the system is safe and reliable. It is also important to have the system inspected by a qualified electrical inspector before it is put into operation. A qualified electrical inspector can verify that the system has been installed correctly and that it meets all applicable codes and standards. The location of the first point of disconnect is a critical safety consideration in any electrical system. The disconnect point should be readily accessible and clearly labeled. This allows personnel to quickly and safely de-energize the system in the event of an emergency or for maintenance purposes. In a solar panel system, the direct current panel with disconnect is typically located near the solar panels. This allows for easy isolation of the solar panels from the rest of the system. The disconnect switch should be clearly labeled to indicate that it disconnects the solar panels. The labeling should comply with the requirements of the NEC. The NEC requires that all electrical equipment be labeled with its voltage and current rating. The labeling should be durable and legible. In addition to the main disconnect switch, there may also be additional disconnect switches located throughout the system. These additional disconnect switches can be used to isolate individual components or circuits. For example, there may be a disconnect switch located at the battery storage system. This allows for easy isolation of the battery storage system from the rest of the system. All disconnect switches should be clearly labeled to indicate the components or circuits they disconnect. The labeling should comply with the requirements of the NEC. When working on electrical equipment, it is essential to follow lockout-tagout procedures. Lockout-tagout procedures are designed to prevent accidental energization of equipment while it is being worked on. Lockout-tagout procedures involve disconnecting the equipment from its power source and attaching a lock and tag to the disconnect switch. The lock and tag prevent anyone from accidentally energizing the equipment while it is being worked on. Only authorized personnel should be allowed to remove the lock and tag. When selecting a direct current panel with disconnect, it is important to choose a panel that is rated for the voltage and current of the solar panels. The panel should also be listed by a recognized testing laboratory such as Underwriters Laboratories or OL. A listed panel has been tested and certified to meet safety standards. The panel should also be constructed of durable materials that are resistant to corrosion. The panel should be installed in a location that is protected from the weather. The panel should be mounted on a sturdy surface. The panel should be accessible for maintenance and repair. The panel should be clearly labeled. When installing a direct current panel with disconnect, it is important to follow the manufacturer's instructions. The instructions will provide detailed information on how to install the panel correctly. The instructions will also provide information on how to wire the panel correctly. It is important to use the correct size and type of wire for the connections. The wires should be properly insulated. The connections should be tight and secure. The direct current panel with disconnect should be inspected regularly to ensure that it is in good working condition. The panel should be inspected for any signs of damage or corrosion. The connections should be checked to ensure that they are tight and secure. The overcurrent protective devices should be tested to ensure that they are functioning properly. Any damaged or corroded components should be replaced immediately. Any loose connections should be tightened immediately. Any malfunctioning overcurrent protective devices should be replaced immediately. Grounding and bonding are critical safety measures in solar panel systems. Proper grounding and bonding protect personnel from electrical shock hazards and prevent damage to equipment. The NEC provides specific requirements for grounding and bonding electrical systems, including solar panel systems. It is essential to follow these requirements to ensure the safety of the installation. The direct current panel with disconnect is a critical component of a solar panel system. The direct current panel with disconnect provides a means to disconnect the solar panels from the rest of the system. The direct current panel with disconnect also provides a means to ground the direct current system. The direct current panel with disconnect should be installed and maintained in accordance with the manufacturer's instructions and all applicable codes and standards. The main disconnect panel serves as the central point for bonding all metallic components within the solar panel system. This comprehensive bonding approach ensures that all metal parts are at the same electrical potential, significantly reducing the risk of electric shock. To achieve effective bonding, connect all metallic enclosures, equipment frames, and other metal parts to the ground bus bar within the main disconnect panel. Use appropriately sized bonding conductors, following the guidelines specified in the NEC. Ensure that all connections are clean, tight, and corrosion resistant to maintain a reliable bond over time. Regular inspection and maintenance of the bonding connections are essential to ensure their continued effectiveness. Check for any signs of corrosion, loose connections, or damage to the bonding conductors. Address any issues promptly to maintain the integrity of the bonding system and ensure the safety of the installation. In addition to grounding and bonding, surge protection is another important safety measure to consider in solar panel systems. Surges can occur due to lightning strikes or other electrical disturbances, and they can damage sensitive electronic equipment. Surge protective devices, or SPDs, are designed to protect equipment from surges by diverting the surge current to ground. SPD should be installed at the direct current panel and at the alternating current panel. The SPD should be sized according to the voltage and current of the system. The SPD should be listed by a recognized testing laboratory, such as UL. When installing SPD, it is important to follow the manufacturer's instructions. The instructions will provide detailed information on how to install the SPD correctly. The instructions will also provide information on how to wire the SPD correctly. It is important to use the correct size and type of wire for the connections. The wire should be properly insulated. The connection should be tight and secure. SPD should be inspected regularly to ensure that they are in good working condition. The SPD should be inspected for any signs of damage or corrosion. The connections should be checked to ensure that they are tight and secure. Any damaged or corroded component should be replaced immediately. Any loose connections should be tightened immediately. Furthermore, consider the specific requirements of the local electrical codes and regulations. These codes may have additional requirements for grounding, bonding, and disconnects in solar panel systems. Consult with a qualified electrical inspector or engineer to ensure that your installation complies with all applicable codes and regulations. Remember that safety should always be the top priority when working with electrical systems. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the installation. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical shock hazards. The purpose of grounding is firstly, to limit the voltage on the electrical system, secondly, protect the electrical system from voltage surges, and thirdly, to provide a low impedance path for fault currents. Bonding, on the other hand, ensures that all metallic parts are at the same electrical potential, reducing the risk of electric shock. The main difference between grounding and bonding is that grounding connects the electrical system to the earth, while bonding connects all metallic parts together. Both grounding and bonding are essential for electrical safety, but they serve different purposes. The grounding conductor should be sized according to the size of the service entrance conductors. The bonding conductor should be sized according to the size of the largest circuit conductor. The grounding electrode should be a ground rod, a ground plate, or a metallic water pipe. The grounding electrode should be located as close as possible to the service entrance. The bonding conductor should be connected to all metallic parts of the electrical system, including the service panel, the meter enclosure, and the equipment grounding conductors. Regular inspections and maintenance are essential for ensuring the continued effectiveness of grounding and bonding systems. Check for any signs of corrosion, loose connections, or damage to the grounding and bonding conductors. Address any issues promptly to maintain the integrity of the grounding and bonding systems and ensure the safety of the installation.